So this is problem 8.17, which was one of the problems on the MyLabs Plus that was due. This one states that there's a 180-pound man, climbs up on a ladder and stops at a position as shown. After he senses that the ladder is on the verge of slipping, the center of gravity of the man is at G, and we're supposed to neglect the weight of the ladder. And we're supposed to determine the coefficient of friction between the pad at A and the ground at the incline, if the incline of the ladder is at 56 degrees and the wall is smooth. So the question is, what does this mean? There's a few key terms in here. One is that it states that the wall is smooth. That means that we, at that point, it will be essentially frictionless at that location. The other key term that we have in here is that it says it is on the verge of slipping. And what that means is that it is our frictional force Fs is equal to mu s times our normal at A. It means that it is actually equal at that location, and that is only because it is at the verge of slipping. Otherwise, that frictional force could be less. Knowing this, the question is, how do we solve this problem? We need to look at our free body diagram. It states that the man is 180 pounds, so we'll write that in here. We have a normal force at B. There is no frictional force. So this is NB. We have another normal force at A, NA. And we have our frictional force. And the frictional force is always in the direction opposite to the movement. It wants to resist the movement. So this is our Fs. And that, again, is equal to, because it's on the verge of slipping, mu A. That would be mu S, right? Our static coefficient of friction times NA. So again, our frictional force is opposing the slipping. This guy wants to, or this ladder wants to slip in that direction. So we are trying to oppose that motion. So that's the motion of the ladder, if it were to slip. Okay? So now let's look at solving this. We can see easily that if we sum forces in the y direction, and if we'll set up our coordinate system, of course, x and y, we see that we have the weight of the man, this 180 pounds, which is going down, plus we have NA. And A is our normal force. That is equal to 180 pounds. Now that we know this, we can solve for this Fs, frictional force, and of course, we know NA. We can solve for our coefficient of friction by solving or summing moments at B. So let's sum moments at B. If we sum moments at B, we have the normal force of 180 pounds, and we need to know this distance that it is going. Of course, this is a positive moment. That distance is really our 10 times the cosine of 56 degrees. This is equal to 56 degrees, it states. So that is that force. Then we have the next one, which is our frictional force. If we look at that, that is going to cause a negative moment, and that is mu s times NA, which is 180 pounds, times the moment arm, which is this height. This height is 10 sine 56. Should be 56, sorry about that. 10 sine 56 degrees. Note that this is our f of s. Last, we have then the moment due to the man standing on the ladder. So that will be a negative moment of 180 times the moment arm of this 3 feet. The only unknown in this equation is this mu s. So now we should be able to solve this. This term, so again, this is equal to 0. The first term is 1006.5 minus our mu s times 1492.3, and then we have our minus 540. We can solve this out. We get mu s is equal to 0.3126. It asks for 3 decimal places. Our mu s equals 0.313. So what that states is that this is the coefficient of friction for the case where this is on the verge of slipping. If he weighed just a little bit more, that ladder would slip out.